Hello dear students, in the last class we have studied some basic formulae that are used in differentiation, and we have solved some simple problems, and we saw how to find velocity from displacement, how to find acceleration from velocity. Okay. Today we will study the reverse process. I have explained in the last class that this differentiation and integration are exactly opposite processes. Differentiation means cutting into many pieces, integration means adding. Okay. We will study one or two basic formulae. Integration of, see, this is the integration symbol. This integration symbol stands for sum. It is an elongated S. Okay. Integration of a constant with respect to x, this is how you read it. Okay, is equal to constant into x plus c. What is this c? C is called integration constant. C is called integration constant. I think some background music is coming. There is some dog outside. Okay, please bear with it. Okay, so for example, integration of 5 with respect to x is equal to 5x plus c. Why this c comes, we will see. Okay, see, last class we have studied differentiation. Differentiation of 2x means what? Differentiation of 2x. 2 comes out. Okay, 2 into dx by dx, correct now? Dx by dx is 1. So differentiation of 2x is 2. What is differentiation of 2x plus 2? What is differentiation of 2x plus 2? Differentiation of 2x plus 2 means differentiation of 2x plus differentiation of 2. Correct now? What is differentiation of 2? It is 0. What is differentiation of 2x? Differentiation of 2x is 2. Now what happened? When you differentiate 2x, you got 2. When you differentiate 2x plus 2, now also you got 2. Now what is the difference? Correct now? See, when you integrate these two, what happens? Integration of 2, okay, integration of 2 with respect to x is equal to what happens? 2 into x. 2 into x. So you integrate this, you should get 2x, correct now? But you took this function, you integrated, you got 2, but when you integrate this 2, you get 2x. This 2 you will not get, correct now? So here in this case, here there is nothing, 2x plus 0. Here there is 2x plus 2. If I take one more example, what is differentiation of 2x plus 7? Differentiation of 2x plus 7 is also 2. But when you integrate this 2, you don't get 2x plus 7, correct now? What is this constant? You cannot predict, you cannot guess. That is why, okay, that is why we write this integration constant c. Okay. Now, next formula that we use is integration of x power n with respect to x is equal to x power n plus 1 divided by n plus 1 plus c, provided n is not equal to minus 1. N is not equal to minus 1. We will see what it is. Okay. One example. Integration of x power 5 with respect to x is equal to x power 5 plus 1 divided by 5 plus 1 plus c, or what happens? This is equal to x power 6 divided by 6 plus c. What if n is equal to minus 1? We will see. Integration of x power minus 1 with respect to x will be equal to x power minus 1 plus 1, means x power 0, divided by minus 1 plus 1. What is this? 0. Correct now? X power 0 divided by 0 means it is not defined. Correct now? It is not defined. So integration of x power n with respect to x is not defined for minus 1. If n is equal to minus 1, it is not defined. But later we are going to study integration of x power minus 1 can be written as 1 by x. Integration of 1 by x will be log x. That we will study later. Now, if there is something called, if there is, say for example, integration of u plus v with respect to x is equal to integration of u with respect to x plus integration of v with respect to x. You can do like this. Okay, means what? Say for example, integration of 5x plus x square with respect to x is equal to integration of 5x with respect to x plus integration of x square with respect to x. What happened? This is constant outside. 5 into integration of x dx. What is integration of x? X means x power 1 is there, correct na? Plus integration of x square with respect to x. It is in the form of integration of x power n. What is the formula? Integration of x power n is equal to x power n plus 1 divided by n plus 1. Correct na? Plus c. Plus c you have to add everywhere. Correct na? Okay. So here what happens? So this is equal to 5 into integration of x power 1 means x power 1 plus 1 divided by 1 plus 1, okay, plus x cube by 3 plus c. So this is equal to 5x square by 2 plus x cube divided by 3 plus c. Hope you can understand how to do it. So if required, I'll give you one more example. Integration of, say for example, integration of t square with respect to t. What happens? Integration of t square with respect to t power n plus 1 divided by n plus 1 plus c. What happens? T cube by 3 plus c. Okay, one more example. Velocity, okay, velocity is given by 5t plus 5 meter per second. Velocity is given by 5t plus 5 meter per second. What is displacement? The question is what is displacement? Then how do you do that? If x is displacement, if you differentiate this x with respect to time, you get velocity. If you differentiate this velocity with respect to time, you get acceleration. Then what is integration? Reverse process. Integration of a with respect to t will give you velocity. Integration of v with respect to t will give you displacement. See, x differentiate v, differentiate a, integrate a, you get v, integrate v, you get x. Hope you can understand. Okay, then how to find this? Then what is x? X equal to integration of v with respect to t. Integration of v with respect to t. So where do I write now? I write somewhere here. Okay. What happened? Okay. So x is equal to integration of v means 5t plus 5 with respect to t. Means what we got? X is equal to integration of 5t with respect to t plus integration of 5 with respect to t. So what happens? X equal to 5 comes out. 5 into integration of t with respect to t. Simply if you write t, there is t power 1 plus integration of a constant with respect to t is equal to constant into t. Correct? Now plus c is there everywhere. Plus c is there. Okay. So what happens? X is equal to 5 into t power 1 plus 1 divided by 1 plus 1 plus 5t plus c. Correct now? So what happened? X is equal to 5t square plus 5t. 5t square plus 5t. Okay, 5t square by 2. 5t square by 2. I have missed this 2 here. Okay. Yeah. If we want to do some circus, okay, say for example, we have this equation, okay, to check our differentiation and calculus skills. Okay, we have this equation x is equal to ut plus half at square. Correct na? What I told you, if you differentiate this x, you should get velocity. Correct na? Okay, velocity is equal to dx by dt is equal to differentiation of ut with respect to t plus differentiation of half a t square. Okay, u is a constant, comes outside. U into what is dt by dt? Dt by dt is 1. Okay, plus half a is a constant, comes outside. Half a into what is differentiation of t square? What is differentiation of t square? Okay, n into t power n minus 1. Correct. Now what happens? 2 into t power 2 minus 1. What happens? 2t. Correct now? 2t. So this is 2t. What happens? This is u plus half a into 2t. What happens? 2 and 2 gets cancelled. Here v. So what do you got? What do you got? We got v is equal to u plus at. Right? V is equal to u plus at. Now you differentiate this once again. What happens? Okay, a equal to dv by dt. We know a equal to dv by dt. So d by dt of what is v? V means u plus at. U plus at. U means what? Initial velocity, that is constant. What is differentiation of u? Differentiation of a constant is equal to 0 plus differentiation of at. What is a? A is a constant outside. A into dt by dt. What is dt by dt? Dt by dt is 1. What happened? Acceleration is a. We know. We knew while deriving these equations, we considered that acceleration is a. Correct now? You differentiate this x is equal to ut plus half at square. You got v is equal to u plus at. You differentiated that equation, then you got acceleration. Acceleration is equal to a itself. Okay. Like this, you can do some. You can take some examples and you can solve some problems. Okay. Now we will see what if the limits are defined. See, in the first 2-3 examples of integration that we have studied, from where to where we have to add, that is not mentioned. Means integration means what? You are adding. Okay. When you are adding a function, say for example, there is a function like this. Okay. So there is a curve. So there is a VT graph. Okay. We know that area under VT graph is equal to displacement. Okay. So if you integrate this, you should know from where to where you have to integrate. What is the initial point and what is the final point, you should know. If you know the initial and final points, okay, during integration, we call it as definite integration. What is definite integration? When a function is integrated between defined limits, then it is called definite integral in general. So if say you want to integrate some function called f of x. Integration of f of x with respect to x, how to read it? Integration of f of x with respect to x between the limits a and b is equal to g of x, means f of x you integrated and you got some function. I call that function as g of x. Now integration is done. Now you write the limits here like this. Okay, lower limit and this is the upper limit. How to apply the limit? In the place of x, first you write the upper limit. In the place of x, first you write the upper limit. Okay, this is g of b, sorry. Okay, upper limit. Then put a minus symbol. Then in the place of x, you write lower limit. This is g of a, g of b minus g of a. This is how you apply limits. See, we will try to understand this by using an example. Okay, using an example. Say for example, integration of x square with respect to x between the limits 0 and 2. Okay, what is integration of x square? What is integration of x square with respect to x? X power n plus 1 divided by n plus 1 between the limits 0 and 2. Hope you can understand. Simple? Yeah. Now, that is equal to x cube divided by cube between the limits 0 and 2. Now, what we have to do? In the place of x, first you put upper limit. Okay, 2 cube by 3. Then you put a minus symbol. Then in the place of x, you put 0. Then what happens? That is 0. What happens? 2 cube is 8. 8 divided by 3. This is how you have to use definite integrations. Okay. Next, say we will solve one or two problems for the understanding purpose. Okay. An electron starting from rest has a velocity that increases linearly with time. Okay, v is equal to kt. What is given? Velocity is given. V is equal to kt, where k is equal to 2 meters per second square. The distance traveled in the first 3 seconds is what they have asked. You calculate distance traveled. Velocity is given. How to find out displacement? Distance is equal to integration of velocity with respect to time. Integration of velocity with respect to time. Correct now? So if you are given displacement, if you differentiate displacement, you get velocity. Now you are given velocity, so you integrate it. Correct now? So that is equal to integration of kt with respect to t. Okay, k is a constant, take it outside. K into integration of t with respect to t. T means what? T power 1 is there, correct na? So x is equal to k into t power 1 plus 1 divided by 1 plus 1 t square by 2. Okay, between the limits. Okay, the distance traveled in the first 3 seconds. First 3 seconds means initially t should be 0 seconds, finally t should be 3 seconds. Then what are the limits? What are the limits? 0 and 3 are the limits. If 0 and 3 are the limits, you write like this. Okay, what is k? What is k? Value of k? Value of k is 2. So this 2 and 2 gets cancelled. Okay, now in the place of t, first you apply the upper limit. What happens? 3 square. Then you put a minus symbol. Then in the place of t, you put lower limit, that is 0. That is 0. Okay, what happens? 3 square is 9. X is equal to 9 meters. So first option. Hope you can understand. Velocity is given. You are asked to find out displacement. What to do? Integration of velocity will give you displacement, whereas differentiation of displacement will give you velocity. Okay, we'll take one more example. The acceleration of a particle varies with time t as a is equal to bt plus c. Acceleration of a particle varies with time t as a is equal to bt plus c. Okay, where b and c are constants. What will be the velocity of the particle which starts from rest after time t? Okay, acceleration is given, velocity you have to find out. A equal to bt plus c. Okay, a is equal to bt plus c. If acceleration is given, how to find velocity? Integrate acceleration, you get velocity. If velocity is given, how to find acceleration? Differentiate velocity, you get acceleration. Correct now. So velocity is equal to integration of a with respect to t is equal to integration of bt plus c. Okay, with respect to t. What happens? V is equal to integration of bt with respect to t plus integration of c with respect to t. What happens? V equal to b is outside, b into integration of t with respect to t plus integration of c with respect to t is constant into t. Correct now? Integration of a constant with respect to t is equal to constant into t. First formula that we have already. Integration of constant with respect to x is equal to constant into x. So integration of t or integration of a constant with respect to t is equal to constant into t. Okay, so in the given problem they have told that c is a constant. Okay, so what is integration of t with respect to t? There is t power 1. Okay, t power 1 plus 1 divided by 1 plus 1, correct na? So what happened? Velocity is equal to b t square by 2 plus ct. Velocity equal to bt square by 2 plus ct. bt square by 2 plus ct. bt square by 2 plus ct. Correct na? This is the answer. But here there is a danger. What is the danger? What they have given, which starts from rest, they have given this point. Sometimes what we will do, sometimes we may directly use this equation. V is equal to u plus at. Okay, V is equal to u plus at. Okay, particle starts from rest, so initial velocity is 0. So this is 0. Okay, so V is equal to a means what? bt plus c. A means bt plus c into t. What happens? V is equal to bt square plus ct. Okay, V is equal to bt square plus ct. bt square plus ct. Option 4. So we have to see when to use integration, when not to use integration. Okay, now what happened here? In the question you have to see acceleration of a particle varies with the time. Acceleration of a particle varies with time. Okay, what is this? V is equal to u plus at. What is this V is equal to u plus at? You have to look at the side heading of the derivation. Kinematic equations for uniform acceleration. V is equal to u plus at, x is equal to ut plus half at square, v square equal to u square plus 2ax. These three equations have to be used only if acceleration is constant. But here in the question, They've told that acceleration is varying with time. So we should not use equations of motion. We have to use integration. Therefore, this is wrong. You have to observe whether the acceleration in the problem is constant or variable. You have to observe. Then you have to solve the problem. Okay. So these last two lectures, okay, basic formula of differentiation, basic formula of integration, you see, observe 1 or 2 times, okay, try to understand, make a notes, okay, which will be very, very helpful for you. Hope you understood this lecture. Thank you very much.